Hi everybody, my name's Nicole. I work with the education department here at the Greensboro Science Center. Welcome back to a Science on the Spot activity. So we're going to be doing a little experiment today with some acids and bases and pH. So all the things I have in front of me right now you might be familiar with. We've got some dish soap and vinegar and carbonated water and things like that. You've probably heard acids and bases before, but may not know exactly what it means. So that is fancy talk for figuring out how the hydrogen ions inside of all of these things work. But we're not going to go into the fancy science of it. We're just going to change the color with it. So what I have right here is some purple cabbage that has gone through the blender with some water. And so purple cabbage has a pigment in it called anthocyanin. Again, really fancy science we're not going to get into. And that purple pigment that's in it will actually interact with the acids and bases that I have here and will change the color. So we are going to mix in the purple cabbage with the 6 items that we have here. We'll see what color they change, and then I'll use a little chart and we can figure out whether they are acids or bases and how strong those acids and bases are based on how deep those colors turn. So we'll start with our vinegar. So we're going to pour in a little bit of our chunky juice. And this is just distilled white vinegar, so it's something that you guys might have around the house at home, but pretty much all vinegars are going to react the same. So we'll pour in some of that. Give it a little slosh around. And sometimes the more you add, the deeper color it will change. So we'll see if we can get this a little bit more, a little bit pinker right there. So if we look at our chart, we see that our purple cabbage has gone to this bright pink color, and that's going to tell us that we are in our acid range. So the pH scale goes from 0 to 14. 7 is right in the middle. That's neutral. That's what most water is. But we have right here, we've got this bright pink color, and so that is telling us we've got an acid with a pH probably around 2 or 3. So that's a pretty strong acid that we have right here. So we'll set that right there. Next, we'll try our carbonated water. So some of you may be familiar with carbonated water, but you might not have ever really considered whether that's an acid or a base. Well, maybe you haven't considered any of these things as being an acid or a base, but we'll see if we can get a nice color change here with our purple cabbage. So this has gone a little bit more blue than our purple cabbage here that we've started with. Maybe a little bit more purple. So you can see this one's a little bit darker than this one is up here. Now we'll try a little bit of baking soda. Now if you've ever made a volcano at home, you've probably mixed your baking soda and your vinegar. So that is an acid interacting with a base. So we probably know this is going to be the opposite of what our vinegar did. So you can see we've got a really deep blue here. So this is a really strong base compared to our acid here. This is probably about 10, maybe 11 on our pH scale. So that's a really strong base, that baking soda we've got right there. Now we've got some lime juice to add into our purple cabbage. I made a mess, a lot of a mess. Now, if you've ever gotten lemon juice inside of a cut, you might have felt it sting a little bit. So that's a pretty good sign that you've got an acid right there. So you can see this turned a really, really deep red. So that might even be darker than our vinegar. So our lime juice, I think, is a stronger base than our vinegar that we have over there. Now this next one you might not have at home and you may not have ever heard of before. So this is some cream of tartar, and this is something that you use sometimes with baking. So we're gonna put some of that in there and we'll see what color it turns, because to be honest, I'm not really sure whether that's an acid or a base. We're gonna have to tell based on our color change that we get in here. So this is going from a kind of purple to a little bit lighter purple, maybe pink color. It's not quite as reddish pink that our lime juice was. So I'd say this is kind of like a fuchsia. So that's going to be probably closer to the 4 or 5 on the pH scale. So it's not quite as low as our vinegar was, or even our lime juice. So we've got this last one here. Again, something you've probably seen before, our nice dish soap. We're going to see what color we can get in here. Now this soap is already blue, but I don't think that that color is going to really affect the color change of our pigment in here. This one we're probably going to have to stir around. And that has gotten really, really dark. So you can compare that with our purple cabbage juice that we have in here, how much darker that has gotten. That's a really deep, deep blue color. So if we had something that was like another cleaning element, something like ammonia, that would actually potentially turn our purple cabbage juice yellow, but that's a little bit stronger of a chemical than we're going to interact with today. So this is probably the deepest color change we're going to get on the side of the base. And I'm going to go get a beaker so that you can see the normal purple cabbage and what that looks like without anything in it. Hopefully you all have enjoyed our experiment today and learned a little bit about pH and the way that the things we have around our house interact with acids and bases. So again, this pigment we have in the purple cabbage is actually found in a lot of different foods, things like purple yams and even in blueberries. So it's something that's really common that we don't typically think about, and we often don't think about the way that the things that we use to cook with or clean with or just enjoy as a nice beverage can actually interact with each other and show us a variety of pHs.